than a programming contest. It is a celebration of algorithmic thinking, creativity, and perseverance. It brings together some of the most talented young minds in our region and challenges them to transform abstract ideas into precise, efficient solutions under real pressure. In doing so, it reflects the very essence of computer science, rigor combined with imagination. For the students competing tomorrow, the contest is an opportunity to test your skills, but also to learn. You will face problems that may initially seem intimidating, even impossible. Yet, through teamwork, logical reasoning, and persistence, clarity will emerge. Regardless of rankings or medals, the experience you gain here will stay with you long after the contest ends. For us, as academics and educators, SEERC represents a shared commitment to excellence in education and research. It strengthens collaboration among universities of Southeastern Europe and highlights the importance of algorithms, data structures, and problem solving as foundation, modern science, technology, and innovation. I would like to sincerely thank the organizing committee, the judges, and the volunteers whose dedication makes this event possible. Their behind-the-scenes work ensures that SEERC maintains its high standards and international reputation. I wish you all a stimulating contest and every success. Welcome to SEERC 2025.
Okay, now I would like to call Mrs. Arianidi, who is a representative of Deputy Minister of Research and Innovation in Greece. Let's welcome her.
That the state budget will be debated in the Greek Parliament this day, so making therefore his presence now is necessary. On behalf of our speaking to you, distinguished organizers, academics, students. As Deputy Minister of Development responsible for research and innovation, I welcome the hosting of the SEERC competition for the first time in Greece. The fact that an institution with 30-year history in Southeastern Europe has entrusted our country and the city of Thessaloniki this year constitutes an indisputable milestone. And we should like to thank the organizers for that as well. The presence of top talents from 8 countries in 4 universities demonstrates that Greece is evolving into a strong hub of technology and innovation in the wider region, capable of hosting events of global significance. At a time when artificial intelligence are reshaping our world, you're the protagonist of the next day. Your participation here, together with the presence of technology giants supporting this initiative, bridges in the best possible way the gap between academic research and the real economy. I congratulate the GRCPC team and the collaborating universities for the organization of this event. Warm congratulations to all the contestants. I wish you every success. Carlos Kalifakis, Deputy Minister for Research and Innovation.
Thank you. That's it. Okay, thank you so much. Now, a small video for the other organizing university, University of Patras. Come on. Όχι πάντα. Εκεί θα την κάνουμε του χρόνου. Εκεί να μάθουμε σε αυτά τα στάδια. έχει πολύ κλείσουν, οπότε θα το κλείσω. Okay, thank you. So, some words about SEERC. SEERC 2025, who we are. There are two sites, one side here, the central site, and another one in Lviv, Ukraine. Right here we have 68 teams in total. 68, isn't it? Yeah, okay. 68 teams in total from 45 universities, 204 participants, 47 coaches, 55 volunteers. Thank you very much. I mean, they really deserve a warm applause, okay? Really. I mean, without the volunteers, nothing would happen anyway. And 12 judges, of course, and organizers. Thank the judges really for the problems that they have provided. Huh?
Especially the judges.
Especially the judges. I mean, we should, I mean, really, they did a lot of work. Okay, so SEERC, what next after SEERC? So the two best teams from SEERC go straight to the World Finals. Okay, so the first two teams go straight to the World Finals. Yeah, one per university always. Okay, not they cannot both best teams can be from the same university. The rest of the 13 teams, one from each university again, will go to the European finals. Yeah, okay, okay. So they go to the European finals that they're going to take place in Poland, Warsaw, start of February 2026. And then we have the World Finals, of course. Up until now, we don't know what exactly will happen, isn't it? Do we know? No, okay, we don't know. We still don't know, so yeah, I can't say anything about that, what's going to happen. It will be great. Yeah, okay, that's a good thing to know. Okay, anyway, so this is the program, the program at a glance. Right now we have the opening ceremony. After that, we have the tech talks from our sponsors. Between 7 and 6, we have the practice session. And then at 6:30, we have dinner, snacks, and drinks at Vasiliko Theatro, which is by the sea, next to the White Tower. It's really great. Don't miss it. Okay, and then you can go around in the center of the city, unless, of course, you want to get ready for tomorrow's competition, of course. So tomorrow we have the competition between 10 and we start at 10 and we end at 3 o'clock. We have also the coaches meeting at between 12 o'clock and 1:30 at room 9. And finally at 6 o'clock, we have the award ceremony at Theater 3 in University of Macedonia, at the premise of University of Macedonia. And then also at the premise of University of Macedonia, we have the a dinner and a closing ceremony in some sense. Okay. So right now I'm gonna show you some videos from our global sponsors, and then the representatives of the global sponsors will come and greet you and say some words, okay, for a minute or more. So we start with Howard.
Θα βάζουμε full screen, όμως μπορούμε. Είναι δύσκολο.
Τώρα μην το αλλάξω. Εντάξει, οκ, δεν πειράζει. Ξέρεις, είναι αυτά τα μικρά σημεία που δεν ήξερα ότι πρέπει να κάνω.
Λίγο εντυπωσιασμό τώρα που το βλέπεις. Λες και είσαι συναυμάμα.
Ναι, οκ, εντάξει. Τώρα μην το αλλάξω και κάνω τα άλλα έτσι.
Εσείς δεν έχετε share screen. Όταν είναι εύκολο βάλτε το, όχι τώρα. Τώρα το ξανασπάω.
Τώρα δεν θα είναι εύκολο μετά βίντεο, γι' αυτό το λέω.
Δεν πειράζει, όταν είναι εύκολο.
Okay, μάλλον όταν ξεκινήσει εσύ θα είναι εύκολο.
Και στο America, άμα είδατε το opening ceremony, κάποια στιγμή δεν ακούγονταν καθόλου.
Ναι, σου λέει το πει.
Δεν πειράζει.
Εντάξει, λοιπόν, κάποια λάθη θα γίνουν, έτσι.
Πρώτη προτεραιότητα είναι ωραίο για αυτούς εδώ.
Ναι,
μικρό βάζουμε το like.
Okay.
Κάνουμε πρώτα να δείξουμε όλα τα βίντεο και μετά να τους καλούμε.
Ναι. Will you please? Το παιδί, will you please? Αυτός που είναι για τη Howard.
Δεν πώς να δεν θυμάμαι. Πρώτα όμως πλάι... Α, τώρα.
Will you please?
transforms. Residents on Russian fields and constantly vision.
No.
Essa coisa mais mudada, né? Vai ser na série.
Ναι, με συγχωρείτε παιδιά. Ξέρω.
We care about we care about the health of our planet and are dedicated to actively protecting it.
Okay. Now we have a video, a small video from JetBrains. Give me just a minute to. Okay.
Παλιώς από εδώ και πέρα δεν είναι όμορφο.
Ποιο?
Το share screen, ναι. Παίρνεις το share screen σε όλους.
Ναι, τι να κάνω τώρα, δεν γίνεται. Θα πρέπει να το κάνω σε να έχω δεύτερη οθόνη.
Οπότε οι άλλοι τι κάνουν το share.
Ξέρω, δεν πειράζει. Μαθαίνω, είδες.
Πρώτη χρονιά στο DRCPC έτσι ήταν. Δεν έμαθε μαθαίνω, κάθε φορά το χειρίστηκα άλλο.
Οκ. Ναι, τώρα στην τελευταία στιγμή. Οκ. Okay. Okay, yeah, let's give them an applause. For Highway as well. Okay. Yeah, it starts again, so yeah, another video from Jane Street, another promoting video.
What makes specifically special for me is that people from many different countries just come together in one place to compete against each other and create a community group.
Many initiatives are going to the same competition here. And that's not like those friends do these competitions, like to this area, so that it's all fun so far.
I have been competing in ICTC for 10 years. What introduced me to a lot of programming, to problem solving. When I first met the facility, I feel I was trying to one thing I would like to do, I use a lot of programming skills I learned during my years in ICTC competition.
I think it's very tricky to simulate SCC and somebody solve a lot of complex and key problems. You know, that really keep connection. And I think it's good that we need to supplement having all expertise in writing.
This is one of the first things students that you We participate in discussions, we share caution. When we look at different things.
You're surrounded by people who care about the same things as. I could give advice to someone meeting today. I would say, make a connection. The most important part is to have your friends. They know. And share fun.
Okay, let's give them an applause as well. And finally, promoting video from vending spoons.
It's. In the video, there's something we cannot mention.
I would say that the listening game would be making it extremely different.
You really, understand that you really want to use this. Very bad.
If you talk to someone at an experience, you will understand that you will genuinely love the company.
In here, there is this we develop a lot of time here and environments, so elements of the we don't really about me today. We try to picture what you can operate I do not believe that great things are possible. You never here.
It's really exciting. It's actually exciting.
Okay. Okay, now I will call to the floor Mr. Pavlos Vouyouklis, who is the principal engineer of Highway, to say a few words and motivate you to stay in the Tech Talk. So let's welcome Panos, Pavlos.
Hi, so Pavlos, I would like to extend a very warm welcome from us, Huawei. We're really excited to share the software. As you saw in our video, Huawei has been recently investing a lot in research to bench both of fundamental blue sky research that seeks to fulfill the PR, but also application-driven research that seeks to make better our products and our entire ecosystem. We maintain strong collaborations with the top universities across the world, and we care a lot about fostering academic initiatives in terms of publishing papers and in terms of challenging benchmarks, open source benchmarking solutions out there. But we also care a lot about products and how we can bring innovation to our own products in order to make them more useful for our customers. This is why we're here today. We want to give you a glimpse of all the problems that we're trying to solve and convince you to come with us and help us make innovation even better.
So next speaker is Pavel Mavrin. Let's warmly welcome Pavel.
Hello, everyone. On behalf of JetBrains, I want to say very proud to be part of this event. We love ICPC very much. We think it's very important what ICPC is doing by bringing you all together. I think it's like the most important part. Okay, most important part is a contest and problems and deciding who is the best and that stuff. Okay, but second important part is it all brings it all together so you can meet each other, so you can meet a lot of people who share the same passion and probably make a lot of friends. So I highly encourage you to, before and after the contest, go and walk around, talk to people, make friends. You may meet your, I don't know, future colleagues, future business partners. I know few people who met their future husbands and wives actually during this competition. So a lot of possibilities. So enjoy. And the great place to meet new people is near the JetBrains booth. So come to us. We try to gather all interesting people around us. So please come and talk to us. So good luck, everyone.
Forgot to say that Pavel is a former world champion, ICPC world champion, so he knows what he's talking about. Okay. So our next speaker is Ivan Milanik, a software engineer from Jane Street. Let's warm it up.
Hello, everyone. My name is Ivan. I'm a software engineer in Jane Street, and I'm very glad to be here. For those of you who do not know Jane Street, this is a company that is doing, this is a trading company. We do provide liquidity to the markets, and we are market makers in a bunch of financial markets. This may sound very cryptic, but just a couple of words to explain what that actually means. There are people who want to buy financial instruments. There are people who want to sell it. Sometimes they are willing to do that at different times. For example, someone wants to sell in the morning, someone wants to buy in the evening. And one option for them is to just wait for the counterparty to show up so you can do the trade. But we are there all the time, willing to do trades with the customers there. And we execute efficiently, and that's the service that we provide, and we take the fee. I know this sounds kind of maybe not that exciting to the ICPC folks, but I just wanted to say that we do have a lot of competitive programmers working at Jane Street, and we are really excited about being a part of this community today, and just giving back to the community as well. I myself was a participant 10 to 15 years ago. I was also participating in SEERC, representing Ivan Franko National University of Lviv from Ukraine. So I'm very excited to be here. Personally, I'm still very fond of the memories that I had when coming here and meeting all the other folks, preparing for the competition. So yeah, I'm very, very excited to be part of all of this. I also want to use this as an opportunity to thank everyone involved in this competition. Too many names to name, really, but I want to start with team coaches who put a massive effort to prepare teams for this competition. I want to thank organizers, hosts, and judges, problem setters, developers of the platform. Everyone really, and most importantly, you competitors. I do think without you that wouldn't be a thing at all. So that's really, really cool to have you here. Yeah, I will be talking about a bit of a strange topic a bit later today. I'm going to cover why OCaml. OCaml is the language that we use in Jane Street for maybe 95% of the code base there. I know this might be not the most obvious choice, but I'll try to justify our decision there in maybe 10 to 20 minutes later today. But I understand that the big day is tomorrow. I just want to wish you all good luck. I want you to show up at your best tomorrow, learn something new, and meet some nice folks along the way. Good luck and have fun. Thank you.
So we have to go a little bit fast. Okay, so some advice before sitting down. I mean, give the floor to Alexandros here. So have fun. Okay, enjoy the competition. Help us make SEERC better. I mean, any comments, anything. We're bound to make mistakes. Okay, this is the first time that happens here in Thessaloniki, so we're bound to make mistakes, but we'll try to correct them in the next year anyway. So. And small diversion to Greek language, we have a word which is called amila. Okay, it's something like noble rivalry. Usually, I mean, if you're antagonizing someone else, then you try to beat him, you try to beat your opponent. However, this is not the spirit of ICPC as far as I understand it, okay? The spirit of ICPC is about getting better. I mean, you should get better with the help of your opponent. So this is, we have a specific word for that in Greek, which is amila. So I wish to you all, I mean, to work with this spirit at your mind. So before sitting down, I will have to. I'm a Star Trek fan, apparently. So I would say to you, live long and prosper. I will change it a little bit and say think deep and solve.
So, hello everyone. I'm glad to have you all here. I'm also Alexandros for whoever. Oh, okay. Oh, yeah, thank you. Well, I want to warm welcome you all here as well. I'm very glad to have you all here. It's very nice. It was a very big organization. We had a very big days, and you will have very big days today and tomorrow. So, some things about the contest. We have some local rules. I hope you all saw them. We have them in both PDFs, in the emails, in the website. I will just say again, please follow them. No contestant is allowed in the contest area. I mean, the volunteers will place you there when it's time, and we will also speak about that a little bit later. Not too long. I will not take too much of your time. And please don't take anything with you at the contest area. No jackets, not bags, not phones, not anything. We will have a luggage place if you want to place them, but nothing in the contest area. Yeah, so. And before the start of the competition, please don't touch any workstation or the materials. You will have 3 copies of the problem sets, all the contestants, because I see many questions. You will have also paper if you want them. You will have anything you need. That happens at every other regional. Yeah. Okay, so for the team reference document, I hope everyone brought their own. You are allowed to have 3 copies per team. You had to bring it at registration. I saw that many were brought. I still know that some teams didn't. I hope you all did, at least the ones you are here. Okay, so I need. Okay, so a little bit about what will happen when you come to the contest area, both today and tomorrow. Every team has a number, and every desk has the number of the team and the name of the team. So before, all teams will come based on their numbers. First, the first 12 teams, from 1 to 12, will come to the contest area, and they will have the time to leave their things in the luggage and go to their desks. Then the next 12 teams, and the next 12 teams, and the next 12 teams, based on their assigned numbers. I will give you the assigned numbers in a little bit. As I said, no food and nothing else is allowed except for medical reasons if you give us any heads up. You need to wear your official t-shirt at every time, especially when you're in the contest area, and your badge. If you are cold or something, you can have it on top of other t-shirts, like I do. You are not allowed to speak to anyone else, other teams. Volunteers will be there to help you if you need to go to the bathrooms, to the restrooms, or anywhere else, and will help you if you have technical problems. But you are not allowed to speak to anyone else, or for any other reasons. You know the specs of the PCs. They are also in the website. If you haven't seen them, you can see them. You will also see them today in the contest session. Okay. I will also say we tried a lot, we have 2 sites. We tried a lot to have as same environment as possible with the second site. It's true, we do have as same as possible to the second site. Also, your workstations is the same that are used for the judge hosts. It's, again, as close as possible to the second site. Just one information before I move to Nikki, who will say a few words for Dom Judge. Well, this year was a little bit tricky for us. We have two judging systems. We have Algo Tester in Ukraine and Dom Judge here, but they work together and as together as possible and with as good results as possible. Only one difference, let's say, that when you see the scoreboard in Dom Judge, you don't see the combined scoreboard. So we have a link in your browsers. You can find the combined scoreboard over there. And you will also probably be will be able to see it in the project. Yeah, so I think Nikki can say a few more things. We're very happy to have both Nikki and Mart here. They are from the Dom Judge contributor team. I think I said correct. And we are very glad to have them here.
Well, thank you, Alex. Yeah, as you might know, we are using Dom Judge here in SEERC for the first time to submit your problems. So I made a small slide. I have some screenshots later on with some notes. You can submit your code in Dom Judge. There's a button. Problem and you pick the language. Select the file. Pro tip: if your file is called after the problem, like A or Py there, it will automatically select problem A and language Python. Do note that for Python we have two versions. We have CPython and PyPy. By default, it will select PyPy because that's the faster one. But if you want CPython, because the newer version explicitly selected. Hold on. Yeah, okay. We also installed a command line submit client. You might not have used it, but it's very fancy. You press type submit and then the file name, and it will automatically submit. You don't even have to log into Dom Judge. Go to the website to do this. That's something that's not on the slide. Know that you're automatically logged into Dom Judge. You don't need a username or password for Dom Judge. Based on which workstation you have, we automatically know who you are. So less password typing, more coding. That's good, I think. In Dom Judge, there's a button to request clarifications, where you can send a message to either the judges or to us for a system thing. If you send a clarification tomorrow for a system thing or a judge thing, probably the answer will be, yeah, it's too late, you should have done it today. So use the practice session today to send any questions you have, any technical issues you have. You can either create a clarification or talk to one of the technical people. You can also find links to all the documentation, so the C, C++, Python, Java documentation, etc., Kotlin documentation. There's a button to print a file. If you want to print a file, you need to do it through Dom Judge. There's a button, you upload the file. It will again automatically detect the syntax, so you get syntax highlighting while printing. Very fancy, and one of the volunteers will bring you the print. Never come and get the print, it will be brought to you. You can also download the sample input and output for the problems and the individual problem statements, as well as the full problem statement of the whole contest you can get from Dom Judge if you want it digitally. You will have it on your desk as well. And the link to the global scoreboard is here, but there is a link on your desktop, so you can better use that so you don't have to remember this. So this is the merged scoreboard together with the Ukraine people. Note that we did some testing, but we'll actually find out today if it actually works. I'm quite confident, but it might be that at the beginning of the contest we need some changes to make it actually work. We'll see. Some screenshots. So this is the submit thingy. If you click it, as you can see, you can select a file, a problem, and a language. For some languages, it needs an entry point, but it will most probably auto-detect. If your file name, if you don't do weird things with file names, it will be defaultly working. Documentation, these are all links. You can find it at the top. As you can see, there's a lot of buttons at the top, but there's also documentation. If you want print a source, it looks quite simple. Select the file, select the language, you click print, and it will be brought to you. This is the page with all the problems, as I said, where you can download the samples and the statements. So I think that's the last thing. One thing I want to note is if you click on your submission, there's a list of all your submissions you did. You get some details, like on what test case it failed, what the time limit, or what the time and memory usage is for each test case. So if you want to know that, you can click on it and it will open a pop-up. And I think that's all I have. Yeah. Thank you. And good luck.
Last
okay.
thing also, yeah, you can check this QR code. Actually, you should, and you will find your team name with your ID. It will be from 1 to 72. Those are the numbers. And you will know your number. So when the contest starts, the first 12 teams will come. So if you're in the first 12, don't be in the back of the room. Be close to the start point. Yeah, and you know how it goes. So that's all from me. Thank you all for coming here, and I wish you have a good time.
Good. Beautiful. Why? Oh, come on. Time to go. No more speeches. Ja, maar een paar uur, hè. 2 uur nog.
Natuurlijk met ook het importeren van die
First, that talk is from the trainer from the bar, out of West Street, so we can start straight away and maybe make a.
Are you heading back as well, or are you still here?
2 minute break.
Okay,
let's say.
I will head back and
Okay.
see you there.
You're staying here?
Yeah, he's staying here.
No, I run again.
See you later. I didn't have anything.
We get you,
Yeah, sure. Yeah, sure.
Will you go down again?
Yeah.
First of all, and we are very thrilled to be part of that. Well, part of this community now. But one thing I want to add is, it's like, we are really solving the problems that are, sorry, what am I supposed to do? Okay. Is it all done? Is it better? Okay. But I still need to speak into this one, right?
Yeah.
Okay. Complicated. Sorry, I was saying that we have like a bunch of folks with the competitive programming background, and I think the like if you really enjoy solving these problems that you're gonna face tomorrow, you may find a career in Jane Street really interesting. Just to give you some like some flavor of the kind of work that we do there, we obviously do not sit all together in front of the same computer and try to type segment tree in the middle of the night with like from the top of our brain. But we do have like an overarching team of like, there is a very difficult problem that was never solved before, and we want to solve it. So we need to break it down into smaller pieces. We need to collaborate together to divide the work and come up with the final solution that is robust, reliable, and correct. So yeah, I think like there is like many similarities that you can like parallel lines that you can connect there as well with the kind of work that is required from a successful ICPC competitor. Yes, maybe like one more thing that I wanted to mention for like the introduction of Jane Street is that we do have, we're obviously a trading company, but we have a very wide range of things that we are working on really. We do have 3,000 people, and we have maybe less than half of that working on a trading desk, as we call it. So this is just like a group of people thinking about trading specific financial instrument. But we do have a bunch of folks working on a very different kind of problems. For example, we have a compilers team that works on improving OCaml compilers specifically to tailor to our needs. And we have like a really good relationship with the open source community there, where we work with them, we support them, and sometimes we push some of our changes that are built internally to the open source community. But a bunch of work is happening internally as well. We do have developer tools. We have and like we have folks that are building developer tools these days. So if like finance is not the thing that is really like interests you, there is like a bunch of other interesting and challenging work that is happening in Jane Street as well. And as I said, we use OCaml in pretty much every corner of the technology that we are building. So that's why I'm just wanted to like chat about that a little bit. Sorry. So to start with, I want to say like trading is scary. And if you don't think it's scary, I'm happy to like talk in a lot more details there. But maybe like a very simple framework to think about is, imagine that you have, you wrote a piece of software. And we all are not really like perfect humans, right? We do make bugs in our code. And now imagine that this piece of software has unlimited access to your bank account, and you start running it, executing like millions of trades every day. If that doesn't scare you, I think like, yeah, then I'm more than happy to chat. But from what I can tell, it's just terrifying, really. So there are a couple of things that we care about when we develop a software. So I think there is like a maybe like a common approach with moving fast and breaking things when we don't exactly follow. There is definitely like a value in moving fast because there is a big advantage of being first to the markets, for example, or being able to prototype quickly something and iterate on that. But in the financial context, breaking things is just like very costly and very bad for your reputation as well. So we do really care a lot about correctness. So every time we write software, we want to be able to reason about it in a good way. So as I said like earlier, we are not perfect humans. We make bugs because like writing code is difficult, but apparently reading code is even more difficult because, well, that's something that happens like a lot more times. You just write code once, you read it like many more times after that. So you do want to have a language that gives you like a nice interface for reading and like understand the code after that. We do care about the performance as well. Some of our trades are executed in like and in a time scale of like nanoseconds, some of them are actually very different, and they are like discussed by humans for weeks to come, and only then like they're executed over like months from that point of time. So performance does matter, but not always. We do care a lot about reliability. So there are many things that can go wrong when you build a software. And maybe like one bad scenario for your application to go down is that some other corner of the company that relies on your application will do some bad trades. Maybe less bad is when your application being down means that you're not doing any trades at all. And like no trades is usually a bit better than doing bad trades, but still like not sustainable for the business. So you do care about like reliability. And then again, I mentioned a little bit about like moving fast. I think agility is valuable as well. And you do want to be able to come up with the prototypes really quickly. Quite often in financial markets, you can spot an opportunity that is right there and you need to capture that. And if you don't do that, it's just like a few weeks later, it's just gone. And you want to be able to react to that quickly. So where does the OCaml fit in all of this? I just want to break down the world of programming languages into two dimensions, where one is dynamically or statically typed, and the other split is imperative or functional. And that's maybe like a rough like outline of the common choices of each of the categories. So let me maybe like talk through some of them quickly. So for dynamically typed languages such as Python, you probably are all familiar with, it's like very easy to prototype with, but they are usually slow in a runtime. And for the statically typed languages, it's sort of like the other way around. It's like development cycle is really slow because you need to wait for the compilation to finish before you can even run the code. But then once you run the code, it's like usually much faster than the dynamically typed. The reason for that being is that for the dynamically typed languages, you can think of the objects that you have in your like program as the values and then variables pointing to these values. And in the dynamically typed languages, values do have types, but variables do not. And in statically typed languages, variables do have types as well, which means that the compiler knows what type of the value and variable they are working with, and they can write the code, they can execute like, the code more efficiently, and you can write the code more efficiently as well. And for the split between like imperative and functional, it's a bit more fuzzy there. I think it's like a good approximation of like what the functional language is the language that allows you to create and operate on the functions easily and pass it around as the data. And I'll show it in a second in a few examples later on. So OCaml is the functional language that is statically typed. I guess like one interesting advantage of the functional languages is that you can also write code in like a pure way. So that means that you can write code that does not require any mutations, and that sort of like simplifies the problem space that you have to think about. I guess I wasn't really familiar with functional languages up until I had a go at Scala. And I remember when I was learning the language, one of the exercises was to implement a set only using languages that is immutable. And I'm like, wait, what? It doesn't make any sense. Like, why would you implement a set with functions, no variables, no mutability? It's just like, how do you even do that? But then like you sit down, you think about it a little bit, and you come up with the solution. And I feel like it just like opens some other dimension in my brain. So I definitely recommend you to at least like give a go at exploring some of the functional languages out there. Okay, how does it work in practice? So here is where I was supposed to show you a bit of a demo. And instead, I'm just going to show you the slides. And I will pick Python as the option for the comparison. So on the left, you have a Python code, and on the right, you have OCaml code. I guess like the program on the left is a very like common way of implementing like a function that adds up all the elements in the list. So like nothing really special there. You just iterate over the list. You have a variable that tracks the total sum, and you keep adding there and return the value. Total variable there is mutable. We are changing it on every iteration, and that's what we return in the end. For the OCaml version on the right, we have a recursive sum that takes a list. And what it does, it checks the representation of a list. And if it's empty, you sort of like know that it's 0 because, well, the sum of empty elements is 0. But if you can split it into the first element and the rest of the elements there, you can say that this is like a recursive call now. So you have a first plus the sum of the rest. And that will give you the same result, obviously, because this is a sum of the elements in the list. But what is interesting here is that the sum function does not modify any state, and it's just like recursively calls itself and increments the value that is returned. Another interesting maybe observation here is that if you do not, if you like suddenly pass not like a list, but you pass a string as an argument, it will fail to compile, and you will get like a feedback from the compiler very early on, and you basically won't be able to even start the program that is not compilable. So that's like another extra layer of security there. When it was like Python, I think it might be a bit more tricky. For example, if you pass like a none instead of a list, this like program may break, even though like that's maybe a reasonable value when you don't have a list. Okay, and maybe onto a more interesting example here. So we want to take two maps and find the mismatches in like both maps. We want to understand like what are the values that are not in the second map, which are in the first. So in Python, you would write it something like this. So you just iterate over the elements of the first map, and you check if if you check if the data in the second map is the same one as the first one, and if it's not, you just like upgrade your list of mismatches. Again, mutable state mismatches. We keep track of all the keys that are mismatching there, and we just return the value. With OCaml, it's a bit more interesting. So you do have to do some like data wrangling here. You transform a map to a sequence, and then on the sequence there is a built-in function like filter map. So you can just like, again, in an immutable way, you take a map and you transform it into something else, creating a new object without ever modifying anything else in the code. And then you have a map.find that takes a map argument and takes the key. And then what's interesting here is that OCaml enforces you to think about the possible values that are returned from the function. So it's not really necessary that you always have a value in a map for a given key. And OCaml actually helps you there. It says like, oh yeah, like it is possible that the value is none, it does not exist. How do you want to handle that? And then you sort of like have to write some code to address that case. And then you have the vanilla case where like, oh, there is some option there, so I'm just going to compare it to data, and then if it is, then I will return some value if they are different, and if not, we just return none. So in comparison, like the code on the left, it compiles well, and I don't think you will get any compilation errors there like at all. The code on the right is compiling as well. Can anyone point out an issue with the Python code there? Sorry, are you saying like it is possible that the key in D2 does not exist, like the key that is from D1 does not exist in D2? Okay, yes, it is possible, but I think that's like sort of like not the case that we care about here. But if we like flip your problem the other way around, it's also a problem. It is possible that there is a key in D1 that does not exist in D2. But in this case, in line 4, we do try to access it. And I haven't checked my Python skills in a while now, so I'm not really sure what's the result there going to be. But I think it might be like undefined behavior or something like that, where you try to access the value for the key that does not exist in the map. And it's very easy to make this mistake, really. And there is not many things that will prevent you from doing that. When in OCaml, you sort of like explicitly have to think about the case where there is the case where the key does not exist in the map. Any questions about that so far? Cool. Okay. And maybe one more thing that I wanted to mention is like in OCaml, we do have algebraic data types. So that's like actually a quite powerful thing that allows you to represent the state of the world in the code quite efficiently and quite like precisely. And if you can represent the state of the world precisely there, that means that usually you can just make less bugs because, well, your code is more like, your code is more realistic and just follows like a general logic in some sense. So one example that I wanted to show here is the case where you just have a bunch of orders. And like you can think of an order as a message that we send to the exchange or like store in logs or whatever, or in the database, doesn't matter. And we want to implement a filter function that takes a possible instruction and filters out all the instructions for a given, sorry, only like keeps the instructions for a given order ID. So I think the type order is maybe like self-explanatory. It just has a bunch of, this is like a record that contains 4 fields. You can have an ID, which is int, price that's float, quantity that's int, and symbol that's string. You can also have an instruction to cancel your order, which takes an order ID and takes a cancel ID as well. Those are 2 different numbers. It doesn't matter really. And then you can have a type of the instruction that is the variant, and it's like a combination of 2 types. It can be either order of type order, or it can be like a cancel of type cancel. I think like right now it's actually quite powerful already to just be able to represent your instructions in that way, to have like everything in one place. I think like in some other languages, you will have to either have both fields for order and cancel and enforce the invariant that one of them is none all the time, which is difficult, or like come up with some other workarounds there. But where it really shines is when you have to implement a filter function. So a filter function just takes the list of instructions and it checks if the instruction is the type of order, then we know what to compare to. Like there is a specific ID field in the order type, or if the type is cancel, then there is a order ID field in the cancel type. So that's how you implement the filter, but that's not the full story there yet. I think what really gets interesting here is that imagine that you get another instruction, for example, reject, and that instruction is reject of type reject, whatever. And you update the code in the type instruction, you mentioned this reject. And what's going to happen next is that the compiler will prevent you from, like, will not compile your code because the match statement at the bottom of the slide is not exhaustive. So OCaml actually enforces you to think about all the cases that might happen, and reject is the new case that is not implemented at that moment of time. So it may be like really simple on this very like example that fits on a single screen, but it gets like really helpful when your code base is spread across multiple files and multiple libraries. So now that you make a change, you sort of like, it's very easy to figure out what are the places where you have to update the logic to maintain your state of the world in a correct way. We even have like a sort of like a joke internally. We say like, if you manage to compile your code after you implemented your feature, you're like 90% done there, because you still need to do the testing, but the compiler is really, really helpful in like helping with catching all the possible bugs as I just like described. Cool. So how does it really work in practice? As I said, like in JStreet, we probably have like 90% of the code base written in OCaml. Although we still try to be like reasonable, and we prefer the right tool for the job. So that usually means that for research, for example, we would prefer OCaml we would prefer Python just because of the really like a great tool set that is available there, and we don't want to like reinvent the wheel. Speaking of reinventing the wheel, we do this sometimes, but when we do that, it's for like a good reason. For example, we have implemented our own data storage that is like very flexible in a sense that it does exactly what it needs to do for our use case, and we are in a full control over there, which is like quite difficult to get when you're using something from the outside. But that being said, we do use a bunch of things that are like open source, and we onboard them in JStreet, and we bring them inside, and we use them heavily as well. One thing that I wanted to mention is that in terms of speed, I often hear questions is like, oh, but like OCaml is very slow. How can you do the like low latency trading with OCaml? And I sort of like want to challenge people on that. Apparently, OCaml is not too slow if you write it properly. So, for example, our trading systems that are, I guess like you can think of a trading execution in like two kinds. One is like on the hardware, the other on the software. And if you trade on the hardware, your latencies are extremely good. And if you're trading on the software, like no matter how well is your software written, if that's like C++ or Camel, Python, doesn't matter, you would never be able to like compete with the hardware really. But what we observe is that for the OCaml, we are actually quite competitive in terms of the latencies with a bunch of the folks that use other languages, like probably C++. Maybe like a trick that we use there is that we try to write code that does not allocate memory in the runtime. So that sort of like helps, because like garbage collection is the thing that is expensive really, and not always predictable in some sense, unless you want to dive really deep. One thing I wanted to cover as well is like if teaching OCaml is difficult, or if it's like difficult to learn it. So we at JStreet do not have any expectations of people joining JStreet to know OCaml. We are more than happy to teach you. And we actually have a very, very good, what we call like boot camp. This is a 2 weeks program where all the new joiners come through. We have a bunch of experts on the topic in the room with you. This is like a actual classroom. Everyone goes into the classroom, work through a bunch of prepared exercises in advance. And we just like have teaching assistants on the side who help you answer all the questions that you may want. And from the experience, after 2 weeks, people are usually quite comfortable to start on their actual team and contribute in OCaml. That being said, we do have like code review, and it's basically like a constant learning. You sort of like get feedback on your code through your code review in JStreet, and eventually you start doing the code review yourself as well. And it's just like a iteration over the iteration there. Sweet. I think that's all that I wanted to cover for today. I would be curious to chat if you have any more questions, but you have any questions that you want to say right now? Anyone? Yeah. Yeah, that's a good question. So you're saying like Rust has many of the same properties here, right? Exactly. And I think you're right. Maybe like a couple of comments here. So we started using OCaml 25 years ago. I think Rust was not around. And that's maybe unfortunate, but a bunch of folks, senior folks in Jane Street are really inspired by inspired by Rust, to the extent that we created our own sort of like branch of OCaml called OxCaml. Ox is like a play of words on like oxidized, because rusty, whatever. And they sort of take the influence from features in Rust and they bring them to OCaml. So I think like OCaml and Rust won't be that different at like some period of time, I think. And we just have like a bunch of code that's already written in OCaml. And it's very difficult to sort of like replace all the ecosystem for the, I don't know, like 3,000 people on the go. But this is like, yeah, this is definitely something that we think about. And I think you're just like right. Any other questions? Okay, great. Thank you so much then. And yeah, good luck tomorrow. Thank you.
You should take it with you. I mean, it's fun. Okay, now I think it's
I'm a principal engineer with Huawei, and I would like to talk about some of the research that we do in Edinburgh. So in Edinburgh, we currently maintain a joint lab with the University of Edinburgh, and a lot of the works that I will be describing come as a collaboration from both Huawei and the University of Edinburgh. The title of the talk is about bridging semantic parsing with retrieval. For those who are not familiar, semantic parsing is the task in which you start with a natural language question and you need to convert this question in some structure format. Maybe this is SQL, maybe this is jQuery. You need to come up with a query that you use against your database instance, and then you query the database instance to get the results. And basically, a lot of the talk will focus on LLMs and how the recent capabilities of LLMs can reshape our question answering capabilities. Being here with you today is actually coming back home, because I actually graduated from the School of Electrical and Computer Engineering. I remember taking exams in differential equations or linear algebra downstairs at the lecture theater downstairs. And I remember at that point I was contemplating about why do we need some expertise in maths and how it would help us in the long run. And like the irony is on me really, because I ended up, this math ended up driving my career afterwards by doing a PhD in deep learning and natural language generation. The postdoc that I did later at the University of Southampton. And since 2019, I joined Huawei, and I've been visiting research signings at King's College in London. And since 2023, I've been leading a small team of research engineers and other software engineers on topic relevant to natural language to SQL, which is the semantic parsing task that I described earlier, retrieval augmented generation, how you can actually retrieve documents in order to make the LLM capability flourish even more, and a topic to which we refer as deep research. So how you can actually use LLMs and the LLM ecosystem in order to do super complex question answering. This is an outline of today's talk. I would focus first about why we care nowadays about large language models and how do people usually train them. Then I will talk about how we can get even better performance out of them by coupling them with retrieval methods. Then how these models can be used for semantic parsing, how you convert natural language into SQL. and then some trends in AI as we see them at Huawei in Edinburgh. I bet that all of you must have heard about large language models these days, but we care during the last years a bit more about them than before. And why is that? So large language models have been there for many years. When I started my PhD, we're still working with hidden Markov models. We have started looking into some other deep neural architectures. We refer to them as recurrent neural networks. And then some better versions of them that we call bidirectional recurrent models based on long short-term memory cells. The first version of CUDA, which has been built by NVIDIA, was officially released in 2007. And NumPy, which is for the people that do not know, this is like the interface that Python used for matrix manipulation, has been in Python even before 2000. Textual data on the web has been there since early 2000s, and we got even more data with the boom of social media, with platforms like Reddit, Twitter, which is now called X, and so on. However, one of the problems that we have had until very recently was modeling long-term dependencies. Modeling long-term dependencies means how we can actually generate text, long text, fluent text. This has been a traditional challenge for the previous model that we see on the left-hand side of the slide, like hidden Markov models, recurrent neural networks, and so on. And these models suffer when it came to dealing with longer sequences. Interestingly, while I was a postdoc at the University of Southampton, we actually submitted a grant in 2018, which was accepted by NVIDIA and granted us hardware for further experiments about how we can generate text that is fluent and coherent and exceeds 2 sentences. So in 2018, generating text longer than 2 sentences, which will be good enough, it was still a challenge. The other thing is about the maturity of the software and hardware ecosystem. Like PyTorch is not even 10 years old, and PyTorch has been a drastic accelerator when it comes to neural network prototyping. First tools of deep learning prototyping, which is the ones that I started with, like the ANO or the Lua version of Torch, were super difficult to use. And then the other thing is that we didn't have the appropriate pipelines for dealing with the computational preprocessing load. One of the results that we see today basically come from our ability to actually train these models on more and more and more data. And we can see even the results by the models that have been released by Meta recently, that Llama 2, the second version of their open weight model, was trained on more than 2 trillion tokens, and Llama 3 steps ahead with 15 trillion tokens. And this actually leads to measurable performance improvements for the model itself. All of this is basically, all of this AI boom that we see wouldn't be here if it wasn't for the transformer. Is there anyone in the room that doesn't know what a transformer is? Great. So the transformer is basically the base of all these large language models like ChatGPT that we use. So all of these models consist of blocks that one can see on the left-hand side of the slide. So in order to build this ChatGPT, we take these blocks or adapted version of these blocks, we stack them together, and this is how we have the large language models that can do so many different tasks. One of the benefits that these architectures have is that they are great for GPU parallelization, and this can facilitate much faster training times compared to the models that we have had before with the recurrent neural networks, hidden Markov models, and so on. The one other benefit is that this self-attention mechanism that you have directly links every token. By token, I mean every word in these long sequences to every other word or token, regardless of distance. So they are really, really good at handling long distance dependencies. And we have found also that they scale much better with size. Models that have been released by OpenAI, Meta, Alibaba, the Tianwen model, they basically take these self-attention blocks, these transformer blocks, they stack them together, and the performance keeps improving as you put more and more transformer blocks. The landscape of AI would be much, much different today if it wasn't for this paper that was released by Google in 2017. It really make us invest millions, billions, if not trillions of dollars into AI. So we put the transformers layers together, we stack them together, and then we have our LLM. How do we train it, though? How do we actually achieve the capabilities that that are advertised these days? So there are all these models are trained in different stages, and people start with unsupervised learning, when you basically use billion tokens of text across the internet. You have some more cleaner data that facilitate the supervised fine-tuning stage. And in this, you can have instruction following data when you have question-answer pairs, and this cleaner data can help the model to become better. And then the most recent trend is about reinforcement learning using human feedback. When you actually collect human annotations, the LLM generates some text. People actually evaluate the text, and the large language model is rewarded when generating high quality sequences, and it's penalized when it doesn't do so well. These are like the two different model variants when it comes to language models based on transformers. One that was very prominent from 2018 to 2020 was the masked language modeling technique, where you have inputs that you mask particular tokens from the input. Like in this case, we mask the token about offer and means. When you have a sequence like words offer the means to meaning. And the main task there is the model tries to learn how to reveal the masked tokens. The other models that is actually what is used today by OpenAI and the big open weight models that people use are the causal language models, when the task is even simpler than the previous one. So basically, the model tries to predict the next word that comes after each word in its input. So when we are at words, we try to predict offer. When we have offer, we try to predict the. When we have the, we try to predict means, and so on. There are models like DeepSeek and one, ChatGPT, and all of these models are basically trained in an unsupervised fashion using web text or on a bit cleaner data when it comes to instruction following data, like the ones that we see at the bottom part, when you have an instruction about brainstorming creative ideas for designing a conference room. You have the output, clean data, the model becomes even better and more refined. And the last bit is about reinforcement learning. When you have a causal language model, it might generate two sequences. And the idea is that when we have humans that actually go and evaluate when a sequence is good and when it's not so good. So in the case of the first one, it's a sequence we like. Humans will go and reward the model accordingly. And if we see a sequence that it's not so preferable, like the one at the bottom, then the model will be penalized, and it will, throughout its training, it will try not to generate sequences like this one. There are a lot of reinforcement learning techniques that have been suggested recently. The most prominent ones are proxy policy optimization, direct preference optimization, and group relevant policy optimization, which was basically proposed very recently by DeepSeek AI, and it's an alternative to the former one. The reinforcement learning has been quite interesting because basically it can make models even of the smaller sizes, and we can see the size of models here going from 1.3 billion parameters. Parameters are basically how the neurons inside these transformer blocks are connected to each other. So models of size from 1.3 billion up to 175, we can see that using the RL methods, which are at the top of this part here, the outputs even from the smaller models are preferred to those of much, much bigger alternatives that are trained with supervised fine-tuning or less other approaches that do not really rely on RL. But when it comes to actually getting the LLM to answer questions, you can go on ChatGPT, for instance, and then you can submit your question and the LLM can answer it. If you go and use OpenAI, there is a particular feature that is called SEERC. So if you have more difficult questions, then the LLM gains the functionality to actually retrieve some website data for you, process this website data, and then give you a more knowledgeable answer. So how do we achieve this? The idea is that we have a lot of text, and for all of these texts, we can represent them using what we call embeddings. Embeddings are basically vectors that try to map the text in a continuous semantic space. So basically texts, like the text that we see here, which is about LeBron James, the popular basketball player, texts that are very similar in semantic meaning will have embeddings that are close to each other in the continuous semantic space. The idea is that we want, if we get a new question, like a simple one in this case, what is LeBron James' position? Then we want to build a prompt that will make the LLM, that will increase the chances that the LLM will generate the correct answer. The idea is that we put in the prompt, at the top part, we put an instruction about the LLM, how it can get the task. Then we try to retrieve, using the embeddings, using computing similarities of those embeddings of the text that we have, we try to compute the most similar texts with respect to the question. We take the most similar texts, we put them in the prompt, we put the question as well, and then we answer. This refers to a framework to which we refer as retrieval augmented generation, and it has actually been great at helping the LLMs answer questions even better. And it can be used even for stylistic transfer. So you want to LLM to mimic a particular way of writing. When you want content freshness, so you don't always go and update the LLM to all the data that exists out there. You have a knowledge base, you update the content in the knowledge base, and then the LLM learns to answer. And then there are other things like how do you do machine translation, how you do natural language to code or natural language to SQL. What happens though, the previous question was very simple. Probably it's one of the questions that the LLM can answer on its own without relying on any external data. What happens if you have a more complicated one, like in what year did Stephen Curry's father join the team from which he started his college basketball career? This is a question to which we refer as multi-hop question, because basically in order to answer it, we need to infer a chain of entities. And using the chain of entities, we are able to get the final answer. This chain of entities can be seen here. Stephen Curry, we go to his father, who is Del Curry. Del Curry studied at Virginia Tech, and he started his basketball career in 1982. If we have such a complicated question, though, how we are able to go and retrieve the most appropriate text that would help the LLM to actually answer the original question? So basically what we try to do in work at Huawei, we try to connect passages with each other. So in this case, we have a set of passages, and these passages include entities. The entities can be about a cathedral in Bremen, and that is dedicated to St. Peter. And then we extract from all these passages all the name entities, and we build triples. The triples can be of this form: Bremen Cathedral dedicated to St. Peter. We do this at scale, and we extract triples massively from all the texts that we have in our index and for which we have embeddings. This allows us to actually bridge text with each other at inference time, because we have passages that share the same entities, and then we can connect those passages to each other. And as a result, we can approximate passages that might be semantically very distant from each other. But let's say that we solve this problem and we have retrieved the documents, like we have a way of retrieving the most appropriate documents, even for very, very difficult questions. How do we include them in the prompt? How do we actually, do we just take all the documents that we have and we have retrieved and we put them in the prompt and the LLM should be answered? We did another collaborative work that we published very recently in 2025, and it was about how we take the content that the retriever gets and how do we actually put them in the context of the LLM? How do we input it to the LLM? Because in this setting, you might have a very capable retriever, and it's able to retrieve what we refer as gold documents. Gold documents are the documents, the texts that are very useful for the LLM to answer. But then you might retrieve some noisy stuff as well. You might retrieve some distractor documents, documents that might contradict the content of the gold ones, or they might not really be relevant when it comes to answering the original question. So we did a study about in this context, what is the ideal scenario for putting the context in the LLM. So we found that the document matters. So performance usually increase when documents are printed in the logical reasoning order. So in this case, in the case of the questions about Stephen Curry's father and his basketball starting career, we need to put documents about Stephen Curry first, then gold documents about Del Curry, Virginia Tech in 1982. We need to try to minimize documents between the distance between gold documents and any noisy documents. So it's very good if we take the full prompt of the LLM and all the important, the gold documents are placed in front. And then we came up with a heuristic idea in order to know, by looking at the attention scores in these transformers blocks that I mentioned earlier, about what is the probability that the LLM answers the question correctly or not. And then the final bit is about how we can leverage this retrieval augmented generation framework in semantic parsing tasks. So let's say that you have a natural language question about count the number of schools that have had basketball matches. And if we wanted to come up with a SQL that we can run against a knowledge base and get the appropriate answers to our question, then we would have a query like this one: select count, distinct school ID from basketball match. So in the context of like using an LLM to get the SQL, the input could be a question in this case: how many degrees does the engineering department have? For a knowledge base, we would have a schema. So the schema is basically a selection of tables. We have 3 different tables here, and each table has some data. And then if we wanted to use an LLM for this, the idea is that we need to build this prompt in which we put schema, we put some values, we put some examples that we want to retrieve, and then we have the question. So when it comes to the question, we just take the question from the input, we put it in the prompt, and we're done. What we found is that we came up with a way of coming up with an approximated SQL that can be used against some examples of question SQL pairs. So we maintain an index of question and SQL pairs. And we came up with an approximated SQL that we basically use in order to quickly determine some question SQL exams that can be included in the prompt that we provide the LLM with in order to improve its performance. And then when it comes to the rest of the elements, we take a SQL version of the schema, and we have some selection strategies that allow us to select the most appropriate values and the most appropriate schema elements in order that should be included in the prompt, rather than including everything, because in some cases the schema might be very long and it might be very expensive for the LLM to run. And then we put everything to the LLM processes this input, and we get the final SQL. This has allowed us to actually challenge some semantic parsing data sets, some open competition benchmarks that have been out there, and one prominent one was the C-Spider, which was captured in 2024. And we found that this framework that we came up with was far more computationally efficient than other alternatives that they go through multiple prompting stages with the LLM. The final section is about trends to AI, and by no means this is not an exhaustive list. So this is a very recent work that we did, and it's about how we can make LLMs better in dealing with math. And we use reinforcement learning for this. And basically, the very cool thing that we do is that we have one LLM, and this LLM tries to become better at solving mathematical problems using self-play. The same LLM, basically in this framework, it alternates 2 roles, teacher and student, without any external supervision. And it comes up with rewards about how, when it assumes the teacher role, how we can generate challenging problems that can be solved by the student, not so easy, so the student can carry on improving. And the very interesting thing is that at the end, we have a very nice selection of topics that the teacher generated with, and we were able to surpass other baselines that were trained on human annotations, which are very expensive to get. And this actually works with just a single trivial seed problem. The other cool direction that's very hot these days is about deep research. So how you can use LLMs that they can use tools and they have access to, they can process your Word documents, they can process your PowerPoint presentation, they can process your Excels, your calculators, like how you can use LLMs at the epicenters of pipelines that they can solve very complicated questions. And the idea that is very interesting is about how close we are at achieving artificial general intelligence. So how good these models are these days and how far we need to go further. There were some very interesting papers by Apple recently, and they basically ask this question whether we are close to achieving it or not. What they found basically is they tested models, they tested some of the very popular LLMs on mathematical reasoning problems. And what they did is that they took benchmarks for which are considered solved by the LLMs that we have today. And they take the test set and they take some minor words in the test set and they replace them. So if the test set includes a name about Sophie, you replace the name with Nick. If there is a nephew, you say niece, and you make some minor changes in the questions. And they found that the performance of the LLM dropped significantly. And this is super interesting because it actually raises questions about whether we have contaminations. Because when we have all these LLMs, these large language models that they train on massive amount of text, there is a chance that the LLMs that we're testing, they have access to the training data and the test cases as well. So when we see super nice scores in all these benchmarks, maybe this is a side effect of these test questions being in the training circle of the LLM. And as a result, what we see as improvement in the reasoning task is basically a result of memorization on data contamination. My take-home message is basically, this is fascinating time for AI. The development of AI capabilities is on steroids. People publish models or updates of the models almost every day. And it's difficult, if you are a researcher in this space, it's very difficult to monitor all the papers that come on a consecutive basis. Some directions that are very promising is improving our way of prompting the models, including the topics relevant to retrieval that I mentioned earlier, and how you can align LLMs with reinforcement learning, how you can make the LLMs better at dealing with the task that you are interested in. When it comes to the generalizability, how we can make all these models generalize even better, currently, the main direction is that we want to place LLMs at the epicenter of complex pipelines, and we want them to act as orchestrators. So we have ecosystems of tools, from browsing the internet to note-taking to using PowerPoint or calculator. You have the LLM, and the LLM becomes efficient not only at generating text and doing what ChatGPT does, but actually using all the tools, taking the outputs of tools, feeding them to another tool, and so on. The other thing that is a bit scary with all the fascinating, with the fascinating time of AI that we find ourselves in, is reproducibility. I think it's very some of these models are very difficult, and the results that we see are very difficult to be reproduced. And we believe that reproducibility should really rely more. We should really rely more on open weight models or open source LLMs in order to increase transparency in AI research. My last point is LLMs are super powerful these days, and you can really take them out of the box and you can apply them to all of sort of tasks. I'm sure that the LLM can perform really well on the competition tests that you have to do today. But you taking an LLM out of the box and just applying it is easy, but understanding the underlying technology is not so much. And actually, there is a lot of value when you have to deal with the systems and make improvements on the actual pipelines. So listen to your math professors, because math is a fundamental knowledge of how all the systems work. And it's a good tool to have in your machinery as you move forward in your career. That's all by me. Thank you very much for listening. Please feel free to get in touch. Any questions? Yes, please.
So we see a lot of hallucinations right now.
Yes.
My agent for projects, my I did more the slide that guidance that's on it for frameworks like
Right. So basically, hallucinations is an open problem. Like they have been there since when these models were starting, and they are still there today. When it comes to like these complicated pipelines, what people try to do, you try to safeguard the input and output coming from a tool. Because in that sense, it's much easier to observe how your pipeline does if you see it isolated, like what is the input output, what is the input output. If you have certain thresholds of responses that you expect, or maybe use a structured language to convert the output of the tool, and then if you get something that is nonsensible, then you will know that the model hallucinated or that the tool was given something which is invalid as an input. So hallucinations are still there, but if you don't see the problem, they are very difficult to detect if you look at the input and the output. But if you use tools, and then a tool can be called within certain constraints, if the LLM hallucinates when it's calling the tool, then the tool will complain. You will know that there is an issue. If the output is not correct, then you can probably have some safeguards there, or you can probably detect it after you take this output and you feed it to the next tool. So this is a way of bypassing the hallucinations problem by like bringing in more the tool usage in the play. I believe that we also have, that was a really good question, by the way. Bingie, is Bingie? Yes. Can you actually help me with this? Any other question? Yes.
Yeah, you're required to model good enough, and the model does not just try to hack the report.
Oh, that's a very interesting question as well. So basically, within the reinforcement learning, this is a problem with the conventional reinforcement learning approach, PPO. So PPO is what OpenAI used originally in 2022, if I'm not mistaken. And basically, like what you're raising is a point that you train a reward model using the annotation that you have collected. And then when you train the LLM tries to hack the reward model and produce responses that are not really good, but they work out very well for the reward model. If I'm not mistaken, DPO, direct policy optimization, doesn't really suffer from this directly. It suffers from other problems, probably, like it tries to generate it suffers from sometimes trying to hack the reward by generating out of distribution samples. GRPO does a bit better. So to answer your question, reward hacking is an issue. People try to normalize this, or they try different reinforcement learning algorithms when it comes to training the model. It's not so easy, and probably another way of hacking it is to have more powerful reward models. So if you generate even more data, if you maybe build even synthetic data and have more humans annotating for you, then you can make the reward better, and then it will be more difficult for the LLM to hack it during a training time. Any more questions? Yes. Of course. Yes, and actually, this is about prompt engineering that I mentioned. You have an original question that you want to give to the LLM, and then you have all other things that you can include in the prompt. And if you have something, a lot of the research that's done focuses also in how you can generate the prompt automatically. What we were seeing here in this work, for instance, this is a work that tries to generate a prompt automatically, like it tries to select the question query pairs that you want. It tries to select the appropriate parts of the schema to be included. It tries to generate a prompt automatically. There are other approaches that go even a step further, and they try to generate the instructions, because based on the query, you try to generate an instruction that would be more suitable for this query and LLM combination. And all these works fall within the region of prompt engineering, and how even when you don't have so much time to go and try yourself to write all possible instructions for the prompt, how you can have a system that generates the prompt on its own, and then it can solve the problem. Because ideally, I personally don't want to go on ChatGPT or whatever LLM that I'm using and try all possible different variations for the instruction. It takes so much time, it's super boring, I'm not interested in that. But there are a lot of works that look into, I have a question, I have this query, I have this draft of an instruction, how we can have a prompt that really addresses my problem. Am I answering your question? Yes. I think it's a super cool direction. I don't know so much about quantum to comment on this, but I think from what I have read and from what I have seen, once we are confident that quantum computers is the thing, we will need to reshape a lot about our understanding about how would these systems benefit and how would they work on quantum hardware. We will need to change a lot. Currently, everything relies on the conventional computer architecture. If we change to quantum, then things will be different. We will need to start all over again. Yes. Can I get one more, please? One final one. A final one. Yeah. Yes, go ahead. I don't think it works like that. I wish I could say this, but generally, when it comes to training the LLM, you need all three different stages. You need to start with unsupervised, and then you go into supervised fine-tuning, and then you do reinforcement learning. For other tasks, maybe you can see benefits by doing supervised learning or reinforcement learning. But when it comes to training the LLM itself, you need findings show that there are benefits from doing all three or more different stages of training. Thank you. Thank you.
Thank you for advertising math as well. I have a problem, convincing my students that discrete math and probability is really, really important. But okay.
Super important.
JetBrains.
That's for mine.
Purple.
Absolutely.
Okay.
You can give it. Just use the laptop. Okay.
Laptop mic?
Yeah.
So I speak here.
Yeah. Just
This one.
over there.
Okay.
The laptop mic
Very
is
big
picking
problem.
up.
Hello everyone. Still live? Oh, okay. 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 I will have it was advertised as a tech talk. It's not very tech. It's talk, but not tech. Okay. So I'm not talking about any technical stuff. I will just talk about some of my mistakes I make during my competitive programming career. So like already told you, so I am ICPC world champion, but I'm actually very old ICPC world champion. It was more than 20 years ago. And okay, I did a lot of competitions before these world finals and after the finals. I'm still doing some competitions. So during this time, I made a lot of mistakes, and I want to talk about them because I don't like when people talk about the success. It's kind of boring for me usually. I think it's much more fun when people talk about their mistakes because mistakes actually teach you something. They teach you some lessons. They make you better. So I want to tell you about some of my mistakes. So you probably learn something. Okay, let's go. So we need to go back actually more than 20, almost 25 years ago. It's Russian Olympiad 2001. It is actually, so it's not the first my failure, but it's maybe the first one which is well documented because it was the first big competition I ever attended. Before that, I attended all the local competitions. I grew up in a small, okay, not very small, but not very large city in the middle of Russia. And so I participate in local competitions and I won all of them, basically. So all competitions in math, informatics, physics. So I like a lot of stuff. That was the first time when I actually go outside and participate in all Russian competition. That's large competition, yeah. And so this is my place. Okay, so sorry, it's in Russian. I was too lazy to translate all the names. So that's me in red. Not that bad actually. Place 15 for the whole Russia. Russia is huge, if you know. Okay, so place 15 is not that bad actually, especially for a person who never attended such competitions. But for me, it was very huge failure because I thought I'm actually the smartest guy in the world because I won all the local competitions. So it was the first time when I actually figured out that I'm not actually the smartest person in the world. Yeah. Devastating, yeah. A few lessons I learned from this contest. First one, I'm not the smartest one, so there are some people who are actually smarter than me, and that's okay. And the second one, even the smarter people than me, they actually train for this competition. So it's not like I just go to the competition and win everything. I just need to train actually. Okay, that was surprising. So I spent the next year training for the competition, and I come back next year. And so that's my result. Yeah, you see, there's a progress. So it's place 6. I would not consider that this actually is a big failure if not this part. So up, I can see. So you see these 3. Yes. So I get these 3 points for the problem, which was solved by basically everyone. That's because that was the easiest problem of the set. So it was very stupid problem. I actually remember the problem even now. I remember my mistakes very well. Okay, no, we don't have time for this. So it's very easy problem, and I make very stupid mistake. And we didn't have feedback that time, so you just submit solution, but after the contest, they show you your result. Brutal system, yes. So I just didn't spend much attention on this problem. I wrote solution, I made stupid mistake, submitted it, and go to the next problem. And that costed me 30 points, actually. And if you see, 30 points will bring me to 3rd place, probably. Yes. It was big mistake, actually, for this contest. And it actually affected me later. So when they selected team for the IUI, they summed these points to points from other contests. And I got to 5th place. But they decided, for some reason, to bring me to IUI instead of Maxim. Still don't know why. I think they made a mistake because you think what happened in IUI. I failed the IUI as well. So that's me. Again, it's not a big failure. It's silver medal of IUI. Yes, was actually many of my students dream about something like this. So, but for me, it was not great. Yes. And I still remember one problem from this contest, which I convinced myself that the problem is solved by greedy algorithm. And I implement greedy algorithm. It passed all the examples, it passed all my tests, and I thought, okay, let's go to the next problem, and didn't think about this problem anymore. And after the contest, again, they didn't have any feedback that time. So after the contest, they tell me, okay, you get 0 point for this problem, congratulations. And I asked why. It's solved by this greasy algorithm, and say why it's solved by greasy algorithm. And I was like, actually, why? I didn't ask this question before. So now every time I think some greasy solve the greasy algorithm, I ask myself why it solved the greasy algorithms. Is it actually true or not? Okay, so that's my contest before I go to university. Then I went to university, so I moved to St. Petersburg, joined IIT University, and we have actually got a great team. I was very lucky that time, so we have two more very smart guys, smarter than me actually, and we had a nice team. And we won all local competitions. And okay, it was called New York that time. It says like NERC now, doesn't matter. So it's our regional competition of Russia and all neighbor countries, doesn't matter. So that's our regional competition, and this is the first large regional competition we participated. So let's look at the results. Can you find the team or team? Okay, so here is it. So it was called IFMO that time because we changed names several times. So since I was starting in university, but I believe we changed name like 3 times because strange times. Okay, so that's my university. So again, you maybe think it's not a failure. So we lost like 3 problems to the leader. But the result is kind of not that bad. It's 6th place, yeah, so not that bad. The problem is it's not my team, so it's team 801. It's actually a good team, so they participated in the World Finals and they got 3rd place in the World Finals. So it's actually a very nice team. To find my team, we need to go a little bit deeper. So we need to go outside here. Okay, Doikens. Losing 4 problems to the leader, but still in top 20. Not that bad, right? The problem is it's not my team also. So it's team ITMO 2. Also a nice team of some, I believe they was like 3rd or 4th year students. They also very great team. I know these guys. So to find my team, you need to go even deeper, actually. So that's my team. So place 28, losing 5 problems to the leader. Just very painful to look at this table, actually. So I remember this contest very well. We made all possible mistakes. In one problem, we read the statement incorrectly, and we just spent an hour solving different problem, which was also solvable, but just a very different solution. And later we find out that we spent hours solving different problem, and we panicked, and we make some more mistakes. So maybe maybe the biggest lesson I learned from that is actually that you don't need to panic during the contest, just never. Even if you make stupid mistake, you just continue doing something. Yes, you never. So if you start panicking, you make 10 more mistakes and you just fail miserably like we did. Okay, again, I believe that's basically because we were too young at that point. So we are just not ready for this major competition that time. That is good because actually we're not team 1. You see, we have team 3. So we have team 1 and team 2 who back up us. And actually team 1 got the gold medals in the World Finals. So it was not a good result for the university, just strange result for us. Yeah. And another lesson from this I actually learned is that you need to trust your coach sometimes. So if your coach tells you you have team number 3, you probably have team number 3. It's not your time, just relax. Okay. Okay, next season is boring because we just won everything. So season 2003, 2004, we just won all competitions. So we learned our mistakes, I think. We won all the local competitions, we won regional competition, we won the World Finals, and all competitions in the middle, I believe we also won. I can't remember any competition we didn't won in this year. Boring year, I told you. So the next year we actually go to the World Finals, and that's our 2nd World Finals in Shanghai. That's my team. Yes. Yeah. We just won the 3rd place gold medal. Can you see happiness in these faces? Okay, that's not because of medals. Just we always look like this. Yeah. So that's our place. Again, it's hard to consider this a failure. Okay, it's the 3rd place, right? With not the bad results, gold medals. Okay, many people dream about this, but for us it was terrible. It's terrible failure. Because we won all the competitions before, and we tried to win this as well. What we did wrong, let me show you. So to see what we did wrong, you need to look at the scoreboard before the freezing time. So 1 hour before the end of the competition, it looked something like this. Again, history. I don't have the actual scoreboard with timings, so I'm not sure about the penalty of the Shanghai University. And I'm actually not sure if they solved 6 or 7. Maybe they solved 7, but just before the freezing. So again, their penalty time was terrible. So they wasn't even close to us. And what happened there, that the whole season we was competing with Moscow University team. We had a very strong team, and we had another strong team in Moscow University with Petr Mitryshev. And again, so in Russia, like St. Petersburg and Moscow are always competing to each other, and especially when you have 2 strong teams. So in all competitions this season, we kind of alternate. So some competitions we won, some competition we lose to Petr. And so that will happen during the finals. The whole contest, we were in the first 2 positions up to the last hour. And so what we thought, so if we solve one more problem during the last hour, and Petr solved another problem during the last hour, they will have better penalty time, and we will also get second place. Second place is not what we want. We wanted to have first place. So what we tried to do, we solved 2 problems at the same time. That's not something unusual for us. We used to do it in the trainings a lot. So we can solve 2 problems. Sometimes we solved it with 3 problems in the last hour. So it's possible, it's doable. But again, it's World Finals, and not everything goes right during the World Finals. Okay. So what happened? We didn't solve anything. Again, let's the finals. That's the final scoreboard. We didn't solve anything. Moscow didn't solve anything, but Shanghai solved the problem and just get the first place. That's it. So what lesson can you learn from this? Hard to tell. I think we actually did everything right. So it's just bad luck. And it's also something that happens. So again, it wasn't a mistake. It was calculated. So it's a calculated decision. We decided to solve 2 problems at the same time. And we could solve problems. We can solve 1 or 2 problems depending on our luck. I remember both problems, actually. Doesn't matter. So just bad luck. It happens. Also, if you look at the results of our university, you can see fun pattern that every second year we got the first place. So I think what we actually did, we just decided we don't want to break this pattern because it was just too beautiful. And actually, it actually continued up to year 2009. So only in year 2009 they decided, okay, we screw it, we will break it, we'll get the first place, and that's it. Okay, so that's my second World Finals. That's how I end my ICPC career. Did I stop failing after that? No, of course not. So that's the most recent failure I did. It was like just 2 weeks ago during the work in Karlsruhe 2 weeks ago. So we participated as a JetBrains team with Nias, and that's the final result. Yeah. So you see, it was very close. You see, it was very close. First, second place actually have the same penalty time. And we just kept a little bit more. And if you count, it's like how many more? 60 minutes, 14 minutes more, right? Yeah, so we're 14 minutes from the first place. And it's like 1 extra wrong submission. And did I make? Yes, of course I did make extra wrong submission. In 1 submit, I just forgot to make define int long. And so it's just a integer flow. That's how we lost the first place in this competition. So again, that happens. It's just because. That's it from me. So good luck to you, everybody, tomorrow. So tomorrow you have a great competition. I hope you will not make the stupid mistake like I did. But if you make stupid mistakes, it's okay. Like in 20 years, you will have a talk about this, and so it will be fine. So good luck, everyone, tomorrow. What? I will have something more to say about our internships.
I will be super fast. So basically, if you would like to work together with Pasha at the same company, we'd be happy to present our internships. And I'll be very, very quick in it, about 3 minutes. As you know, many of you are using our tools. Our tools are installed on the computers here, so please feel free to use them. And also, if you're writing in Kotlin and submits correct submissions, so come to us, you will get your prizes after it. We do have offices in very different locations, and we do propose internships in a variety of countries, mostly European ones. So please do check our internships. They're super fun. We do have people here with us who are responsible for internships as professionals. We do have interns with us here at the booth. We have our student ambassadors. So just jump in to talk with them. What makes us special is that you are choosing the specific internship that you find most interesting exactly for you. We do have the list of everything that is needed from the intern. So it's super interesting in terms of that you are working exactly on the project that you find most attractive. So how it works, you need to go to our platform, you are logging in there, and we have the full list of internships that are available. They're available in the round. So currently we have the round specifically open for the ICPC participants. You can check them out. And those are available till January 5th when you need to apply there. You'll get a small test task back. You can make it in either 1 or 7 days. It depends on the very specific internship. And then go to talk to your mentor and go there at JetBrains. Super easy breezy. So feel free to come to us. We do propose some relocation within Europe. So if you want to join us during the academic year or either during summer, we have very different options for it. Come to talk to us. And indeed, join us in our successes and failures. Thank you.
Thank you so much. Thanks, Pavel, for the very nice insights. So now the last talk is from the Gold local sponsors, Yodek. So please, we have 5 to 10 minutes. Is it okay? Sorry about that, but it took us a lot of time. Okay. Okay. Έχεις, κάτσε να βγω εγώ, απλά βάλ' το στο... Πες το Zoom και θα σε δεχτώ.